Hey guys, it's Mr. C here with our first flipped lesson this year. Woohoo. Um, we're going into chapter 8 now. Um, chapter 8 is all about different transformations, and each lesson in the chapter just about covers a different type of transformation. So the first one that we're going to be looking at is called a translation. And if you're taking notes, which I would advise, you can see on the screen here, you've got a translation is a transformation. So it's a type of transformation that moves each point of a figure the same distance and in the same direction. So I've got a little picture right here to kind of give you a visual of what a translation looks like. You might know it as a different word. I'm actually going to write this down. It kind of looks like the picture is sliding. So just a quick one-word definition, if you wanted, for translation is a slide. So you can see the black figure is translating over and then down, and then it was redrawn with blue so that you can see the new figure. And that's all a translation is. You're kind of like sliding a figure over. You can move it left or right, up or down, and any combination of moves, and then you get a new figure. And just a couple of other things before we try a few examples of these. Um, the figure you get after any type of transformation, whether it's a translation or any other kind of transformation that we do, is called an image. So the black figure here is your original, and the blue figure is the image. All right, we talked about image last chapter a little bit. And also, you'll notice that the blue figure has the same points as the original QPR, QPR, and the only difference is the Q, the R, and the P have these little, it looks like an apostrophe after the letter. What that is known as in math is prime notation. And what prime notation does is it signifies to us which figure is the original and which figure is the image. The image always gets the prime notation. So once you're done doing whatever transformation you're doing, you'll redraw your figure, label it, but instead of just using the same letters, it'll be the same letters with prime notation. So you would read those letters as P prime, R prime, and Q prime. That's what the little apostrophe looking thing is. So it's important to just cover your bases, make sure that the details when you're working with this are clear. Don't leave out the prime notation, because if it wasn't there, we wouldn't know which is the original, which is the image, and it can kind of get you screwed up. So just be careful with that. So with that all being said, and you can pause the video if you need to. If you're writing or just need to see it again, you can rewind it. But I'm going to move on to an example of a translation. So triangle JKL has vertices at 0, 2, 3, 4, and 5, 1. And it wants us to translate the triangle 4 units to the left and 5 units up, and then list the new coordinates. Well, actually, it's just asking for the new coordinate of J prime. So let us graph these. So 0, 2 would be right here, and that's J. K is at 3, 4. Okay. If you haven't graphed in a while, just refresh yourself with a coordinate plane. All right, we've got quadrant 1, quadrant 2, 3, and 4. We've got your x-axis and your y-axis. And if graphing is not one of your strong points, just ask me for a little extra practice and we can go over it in class. All right, so there's our original figure, JKL triangle, and we're going to translate it 4 units to the left and 5 units up. So translations are pretty easy. You're going to take each point and do exactly what it told you to do. I'm going to start with point J. I'm going to move it 4 units to the left. So 1, 2, 3, 4, and then 5 units up. 1, 2, 3, 4, 5. And that is where I've got my new J prime. And let's do the same thing for the other points. So k, 1, 2, 3, 4, 1, 2, 3, 4, 5. All right, and now I've got k prime. And then lastly, I need to move point L over, so 1, 2, 3, 4, 5, and then, over 4, 4, and then up 5, 1, 2, 3, 4, 5, right on the y-axis. All right, and there's my new figure. That's the image, the prime notation. Okay, so I have JKL, J prime, K prime, L prime. And that's all there is to translations. And there's a few other things that we're going to look at with translations. One of those things is the fact that the image of a translation is always congruent, exactly congruent to the original figure. So if we look at these two things, you'll notice that their line segments are exactly the same length, and if we could measure their angles, and mine obviously aren't drawn perfectly, but if we could measure them, they're exactly the same. So it's important to note that translations do not change the shape or the size. All they change is the position of the shape. Originally it was here, and now it's here. All right? Otherwise, nothing else changes, just where it was located. Another thing that we're going to look at really quickly is called arrow notation. Arrow notation is just it's just a way to describe where your original point was and then where the new point ended up at. So for this example that I have right here, I have my original points at -5, 1, -1, 4, and -2, 2. And then the new points were at 1, -2, 5, 1, and 4, -1. Literally, it's the original coordinates, an arrow, and then the prime notation of the coordinates at their new resting place. So if you ever see directions, or if I ask you to use arrow notation to describe a translation, all you are doing is writing your original coordinates followed by an arrow and then the new coordinates. And it just lets us know that they started here and ended here through whatever translation happened. All right? And the last thing that we're going to look at in this section is writing a rule to describe a translation. So I'm looking at the exact same example from the very first slide, QPR, and then Q prime, P prime, R prime. To write a rule for a translation, it can be a little bit tricky at first, but you just need to see it once or twice to pick up on it. A rule is described with arrow notation, and you always start with just a regular old X and a regular old Y, followed by an arrow, and then you look at what happened in terms of the X-axis. So what happened? Did we move left or did we move right? And in this example, we moved each point to the right 1, 2, 3, 4, 5, 6. All right, you can count for all of them if you want. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we went to the right 6 units, and then Y tells us, did we go up or did we go down? Okay? Oops. And in this example, you can see we went down 1, 2, 3. 1, 2, 3. 1, 2, 3. Each of the points went down 3 units. What I've just written out for you right here is a rule that describes the translation that occurred. Every point went to the right 6, so plus 6, and went down 3, minus 3. So all you need to know for rules is when to use addition in the rule and when to use subtraction. So here it is. Addition describes if you're either moving to the right, like in this example, we moved the points to the right, so we used addition to describe the x. And it also describes moving up. So if we move these points up instead of down, it would have been y plus 3 instead of y minus 3. Subtraction, on the other hand, is used to describe anything that moves to the left and anything that moves down. So if these points move to the left instead of to the right, it would be x minus 6 instead of x plus 6. And we've already seen an example of minus moving down, subtraction moving down, y minus 3 because we moved down 3. All right, maybe that's a little bit confusing, but I think it helps just to do a few examples with this. So let's look at another example, and I'm going to scroll back up so that you can see and remember, what does addition do, what does subtraction do. So first, you've got to determine what's the original and what's the image. This is a great example of why it's important to have prime notation. Now I know that this is where I started, this is where I ended. So you got to figure out, what did I do? Did I move to the right? Did I move left? Did I move up? Did I move down? So I'm going to just pick S. I started here and my new S is over here. So it looks like I went 1, 2, 3, 4. I went 4 to the right and 1, 2 down. So I just would double check with the other points. 1, 2, 3, 4, 1, 2. So from R to R prime, I also moved 4 to the right and 2 down. And in T, I moved 1, 2, 3, 4 to the right and 2 down. So when I'm writing a rule for this, okay, what happened? I moved to the right. So addition describes moves to the right. So plus 4. And let's see, did I move up or down? I moved down. Subtraction describes moves that are downwards. And we moved down 2. And that's the rule for this translation. That's all there is to it. So really the only trick is you have to remember that addition is to the right and up. Subtraction is to the left and down. And you can write a rule for pretty much any translation that you do. We'll do one more example. Maybe it's on the other page. Yep. Okay, write a rule that describes the translation shown, that should say shown on the graph below. Grammar police. All right, shown on the graph below. Again, look at your original, look at your image. If you want to try this without seeing me do it, pause the video, write out a rule that you think it is, and then unpause the video and see if you're right. So if you unpause the video to see if you're correct, I would say the rule should be X, Y. All right, so X, we move to the right, obviously. 1, 2, 3, 4, 5, 6. So plus 6. And then this is an example in which we moved up instead of down, so this is also going to be plus. So 1, 2, 3, 4, 5, 6. 1, 2, plus 2, we move 2 up. And there's the rule. So this is pretty much all there is to translations, all right? So the 3 things we basically have done is translated stuff. So can you actually do a translation? 2, can you describe your translation with arrow notation? And 3, can you describe your translation with a rule? And that's what we've been doing the last couple of examples. That's all there is to this part of the chapter. So I've got for you 3 summary questions. I will scroll down a little bit so you can see the third one. Pause the video. I want you to write the questions down in your notebook and then answer them and have those ready for me tomorrow to look at, just to make sure that you actually looked at the video, went over the lesson, and we'll do some practice in class and bring any questions that you might have to me tomorrow, or you can email them to me if you think you're going to forget, or write them in your notebook. Either of those options works. But here's your summary questions. Pause the video at some point, write them down, give them a try. If you get stuck, go back, rewatch the video, rewatch the examples, and hopefully I did a good job of Chapter 8, Section 1, and that's it. So again, I'm going to scroll down real quick so you can see all of the questions. Okay, and I will see you in class mañana.